guys, this is Ronit from Mathx, and today we are going to be calculating how fast Santa would have to travel to have had to deliver all of his presents. Now, this is a question that people have tried to solve many times before. But I feel we can find this out using some elbow grease and math. So let's cut to the chase and find the speed of this red magic machine. First thing we would need to discover is how much would Santa have to travel. And we can find this amount relatively easily by using the good old method of Google search. One thing that would definitely be useful to search up here is the surface of the Earth itself. Because when we find this, we can find the total amount of land of the Earth, and we can probably find the number of houses and the distance between each of them. So, using the surface area of the Earth, which I found out to be 196 million miles squared, which if you think about, that's a really big number. Very huge. But that's not all the land. That's also including all the water of the Earth. And since 70% of the Earth is water, fun fact, and I'm assuming that there's no sea people on Santa's list, like mermaids, but I could be wrong. Anyways, we would need to find 30% of the 196 million miles squared, which is roughly 59 million miles squared. But there's a slight problem here. You see, we're including one continent that doesn't have any permanent human establishment there, and that is Antarctica. And Antarctica doesn't have any permanent humans living there. So Santa doesn't need to go to Antarctica to just deliver no presents, unless we count the penguins. If so, Santa has almost 20 million gifts to deliver, assuming all the penguins have been good this year, which they probably haven't. Anyways, if we subtract the 5.275 million miles squared from the 59 million miles squared of land on the Earth, we get 54.725 million miles squared, which will just round to 55 million miles squared, since we want to make the trip hard on Santa. Now with that 55 million miles, we can find the average amount of people per square mile. Now, since there are 8 billion people on Earth, we can just do the division of 8 billion divided by the 55 million miles squared. This helps us understand how many gifts Santa would have to deliver per mile as he goes on. We end up with a result of 145 people per square mile when we rounded. We can then research the average amount of people in a household, which varies from country to country. For the USA, it's 2.5 people, which on a side note is kind of freaky. If I saw that normally 2.5 people just live in a household without context, I'd be pretty concerned, since they have half a person just chilling in their home. But continuing on, we see that the average number of people in China is 2.98, and in India it's 4.4. So I just did the in-between option of 3 people, because I'm not going to count half a person like a psychopath. So 145 people per 3 people to find the amount of houses per square mile, which is roughly 49 houses per square mile. Now to put these houses at an even distance from one another, we would create a 7 by 7 square, so that all houses are evenly spread out from each other. And it would take 8 miles to travel to all of them in total, since we would have the 1 mile for each of those rows and 1 mile traveling downwards. So we would have 7 of those rows, so 7 miles, and 1 mile when you're traveling down or up, in whichever way you decide to go with your rows, and that would be like 8 miles. So when we multiply these 8 miles back into the 55 million square miles from before, we get 440 miles of pure sleigh riding for Santa, which seems like a slayer's dream. But If you do this for a long time, you'd probably get really, really tired from all of that sleigh riding. But our final step here is to use a simple distance equals rate times time equation. Our distance here is 440 million miles. And we also have the time for Santa, from when children go to sleep to when they rise, which is roughly from 11 p.m. to 7 a.m., so 8 hours. So when we do the calculations here, Santa would have to travel almost 55 million miles per hour. And that means that Santa's sleigh would be traveling 50,278 miles a second. To put that into perspective, Santa could travel to the moon and back in half a minute. That speed is probably enough to let Santa into the Flash family. Just imagine Santa hanging out with the Flash, Barry Allen, Kid Flash, all those Flashers. Well, while it has been said how Santa is more powerful than both Superman and Flash, and is one of the most powerful characters in Marvel, you see, the power of elves, his entire army could probably destroy us all. But that's another story for another day. Anyways, have a jolly holidays, and thanks for watching.
Jingle bell, jingle bell, jingle bell rock. Jingle bells